In the United States, IoT-powered consumer electronics are gaining popularity because of their ability to remotely monitor and interact with the physical world. While we continue to develop more advanced consumer technologies, much of the world still struggles with unreliable infrastructure. As climate conditions become more volatile in these regions, it is more important than ever to optimally manage limited resources. Our project, the Intelligent Irrigation System, aims to address these concerns in three key ways. First, it allows small-scale farmers to efficiently distribute limited water to different portions of their lands. Second, it creates the potential to plan for periods of harsh weather conditions as these events become more frequent. Third, it empowers farmers with the ability to monitor soil moisture and to allocate water remotely.
The system architecture for the Intelligent Irrigation System is displayed here. On the left-hand side of the screen, two soil moisture sensors are attached to remote Arduinos, both of which are connected to control valves and Zigbee S1 radios. The Zigbee radios send the soil moisture readings through the mesh network to the controller Zigbee and onto the main ESP controller. The ESP sends the soil data to an AWS server, which stores the information and performs data analytics based on the moisture trends and predicted weather data. Data processing is accomplished with a regression model developed in Flask, and the weather forecasts are retrieved from openweathermap.org. The relevant information is then passed on to the mobile application, where it is seen by a user and used to make informed irrigation decisions. A valve command generated by the user in the application follows the reverse pathway, which is shown by the dashed green line. The command reaches the main controller through the AWS server and is forwarded through the Zigbee mesh to the corresponding microcontroller and valve. An execution of the valve command is shown in the following video. This is the Intelligent Irrigation System prototype. Here we will show you how you can send a command from a phone to irrigate a plant. The information flow is as follows. First, a command is sent from the phone up to the cloud. The cloud then sends the command to the coordinator Zigbee, which sends it to the receiver Zigbee. The receiver Zigbee then sends a valve command to open a valve that is connected to a tank. At which point, water begins flowing into the plant, where the moisture is recorded by a sensor in the field. Here is the main interface for the IIS app developed for Android. By clicking Sensor Display, the app displays soil moisture readings at both remote sensors. This display also shows the relevant weather data and information about the timing of future watering events, including by when each area of soil needs to be watered. The buttons on the bottom of the screen allow the user to input a time and open either Valve 1 or Valve 2 for this period of time. The second screen, which is reached by pressing Next in the top right of the interface, shows the temperature and humidity information. As with the soil moisture data, the user can determine how often these readings are sent to the cloud. The user can retrieve the new information by pressing the display button again.
Our project employs the Zigbee mesh network, which can be used to relay soil moisture data generated out in the field back to the controller, where it can be reported to the user. The mesh network allows for scalability far beyond what you could get from a traditional point-to-point radio system.
We believe that the Intelligent Irrigation System offers the convenience and capabilities of modern IoT technologies to a profession that can truly benefit from these advances, small-scale farming. As a bonus, it is also very easy to install. All you need to do is place your IIS in your field, connect to your water line, and enjoy full control over your farmland.